Question 4 shows us a quadrilateral ABCD, and it says construct an accurate drawing of ABCD. AC has been drawn for you. So we can see that there's an angle at A, a 50-degree angle, and the length of AD is 4.5. So what you will do is you will open your compass to 4.5 centimeters. You will put the pointer at A and draw an arc over here from that 4.5 centimeter measurement. So I'm just going to assume this is 4.5, and you will make sure that when you draw the line, you measure this angle over here using a protractor, and this angle needs to be 50. So you put the protractor over here, measure this angle over here, wherever it's 50, you draw your line from that point towards the arc. So this is where your point D will be, and this would be 4.5, and this would be your 50 degrees. Then next we have to draw AB and BC. So AB is 8 and BC is 6. So for AB, you will first open your compass to 8 centimeters and draw an arc over here. This should be 8 centimeters. And for C over here, from C to B, that's going to be 6 centimeters. So you draw an arc from C over here, and that's probably going to touch somewhere over here. You connect both of them, and that would give your shape over here. And then in the next part, they're asking us to measure angle ADC. So once you have drawn the shape using your protractor, you will put the protractor at D and measure the measurement. And then by taking a suitable measurement from your diagram, find the perimeter of quadrilateral ABCD. For that, you will measure your distance of DC, because you already have all the three lengths. And then once you have DC, you just add them up and you will have your perimeter. In part B, it says the diagram shows a cuboid. TW is 15 centimeters, WV is 10 centimeters, and RV is 8 centimeters. Show that TR is equal to 19.7 centimeter, correct to 1 decimal place. So now first, we will join T and V over here. So if you look at this, this is a right angle triangle over here. What we need to find is TR and show that that equals to 19.7. And we can easily do that if we first find VT, and then using Pythagoras, we can also find RT and show that it's 19.7. So first, I'm going to label VT as X, because that's what we're going to find using the Pythagoras theorem, because this is also a 90 degree. So VT square is going to equal to TW square plus WV square. So that's X square equals to 15 square plus 10 square. X square is equal to 15 square is 225 plus 100, that's 325. So now we find the square root of 325, which is going to equal to 18.003. Yeah. So now VT is 18.03. So now I'm going to use that to find RT. So RT in this case is the hypotenuse of this right angle triangle. So RT square is going to equal to RV square plus T V square. So that is going to be 8 square plus 18.03 square equals to RT square. RT square is 18.03 square is 325 plus 64. So square root of 389 is going to be 19.7, which is what the question was asking us to prove. Then in the next part, it says X is the midpoint of PQ. Calculate angle TRX. So this is what we're going to focus on. X is the midpoint of PQ, so that means this is going to be 5 and this is going to be 5 because VW, RS, PQ, and UT are all the same. So we already found TR, which is 19.7. What we will do is, we know if RV is 8, SV is also 8, and PT is also 8. QU is also going to be 8. And over here, if WT is 15, that means PS is also 15 and QR is also 15. So if we look over here, we have two right angle triangles again, and we're going to use those to find XT and XR. So let's start with XT first. XT square is going to be 5 square plus 8 square. Why? Because XT is the hypotenuse of this right angle triangle, XPT. So XT square equals to 25 plus 64. And XT is the square root of 89. And that equals 9.43. Now we find Rx. So Rx square, once again it's the hypotenuse, equals to 5 square plus 15 square, which is Qx square and Qr square. Rx square equals to 25 plus 225, which leaves us with Rx equals to square root of 250, and square root of 250 is 15.81. Now that we have the lengths, 15.81 over here, 9.43 over here. So what we will do now is, we have three lengths and we have to find angle PRX. PRX is what we have to find. So what we will do is, we will use cosine. Why we will use cosine? Because this triangle over here, triangle XRT, is not a right angle, it's a non-right angle triangle. And in non-right angle triangle, if you have like three lengths given and they're asking you to find one of the angles, you will use cosine. For example, if there were two lengths given and the angle between it, and they were asking us to find the third length, so then you could also use cosine. So in this case, since it meets the condition for the cosine rule, which is the availability of three lengths and an angle, so we will do cos of x r t equals your xt square minus xr square minus rt square divided by -2 times xr times rt. So cos of xrt equals xt is 9.43 XR is 15.81 and RT is 19.7 divided by -2 times 15.81 times 19.7. So now let's solve that. So cos of XRT is now equal to 0.88153. Now we take inverse of this. So XRT is equal to cos inverse of 0.88153, and that is going to equal to 28.2 degrees. 5 says shade the subset A complement intersection B complement intersection C. So A complement is basically going to be that set that does not include A. So this entire thing goes out. And B intersection C is just this part. So this is our shaded region. So if you look at part B of question number 5, it says that our universal set contains the alphabets A, C, E, G, H, J, N, R, T, Z. W has those elements which has a rotational symmetry of order 2, and X has those elements which have a line of symmetry. And Y has the alphabets R, A, N, G, E. Those who have a rotational symmetry of order 2, that's going to include H, N, and Z. Why? Because when we rotate these 3 alphabets 2 times, they're going to go back to their original shape. Whereas for the other ones, if you rotate them 2 times, they will not go back to their original shape. Because look, if we rotate H goes like this. That's the first rotation, and then second rotation, it's the same. Same for N. First rotation is going to be like this, and second rotation is the same thing. And for Z, same thing. It's going to first look like an N, and then it's going to go back to itself. So this shows that these 3 elements have a rotational symmetry of order 2. Then if we talk about the line of symmetry, for the line of symmetry now, A has a line of symmetry, C has a line of symmetry, E has a line of symmetry, H has a line of symmetry, and T has a line of symmetry. A, C, E, H, T. Yeah. Everyone else does not have a line of symmetry. Why? Because if we make A, this is the line of symmetry for A. For C, this is your line of symmetry. For H, you have a line of symmetry like this and like this. Then for T, this is your line of symmetry. So this is how you determine where the line of symmetry lies and the rotational symmetry of order. Now, if we talk about putting these down over here now, W is H, N, and Z. X is A, C, E, H, T. And Y is R, A, N, G, E. So now we know that E is common between X and Y. So E comes over here, and so does A. So I'm just going to write A and E over here and remove these 2 from here. Now, H, N, and Z, we can see that N is common between W and Y. So N comes over here, and we remove N from here. And between W and X, we have H common. So that comes over here. So which alphabets are left now? R, A, N, G, E's have been taken. So J is outside. And The G is also taken, H, J, N, R, T, Z. Yeah. So this is the complete Venn diagram. Now in the next part, it says list the elements of X intersection complement of W union Y. So first, let's write W union Y. W union Y will include all the elements of W and Y. So that's H, N, Z, R, G, A, and E. So since we're talking about the complement of W union Y, that's everything else that is not a part of W union Y. So that's J, C, and T. Next step is intersection of X with complement of W union Y. So that's just C and T, not J. So this is your answer for this. Then it's asking us to write down the number of W union X union Y complement. So that's J, because that's the only element that's not a part of W, X, and Y. Then it says using set notation, complete the statement blank equals to a null set. So if you go back to our Venn diagram, the only place where there's a null set is in the middle. There's nothing common between all three of them at the same time, which means our null set is going to be W intersection U, W intersection X, and intersection Y. This is our null set. Question 6 says we have two functions. Function f is 2x plus 3 and function g is 12 minus 3x over 5. Part A says find g of -1. So we substitute x equals to -1 in this function. And what we have is 12 minus 3 times -1 over 5, which is 12 plus 3 over 5, 15 over 5, and that is 3. Then it says solve f of x equals to 2. So 2 equals to 2x plus 3. 2 minus 3 equals to 2x, and -1 over 2 is your x. Part C says find g inverse of x. So g of x is 12 minus 3x over 5. 12 minus 3x over 5. I'm going to put the function equal to y first. Now, right now, the function has y as the subject. We're going to make x the subject. So we multiply 5 with y and get rid of the fraction. Then I'm going to swap 5y with 3x. So it's going to be 3x equals to 12 minus 5y. And then x is going to equal to 12 minus 5y divided by 3. Last step is going to be replacing x with g inverse of x and y with x. So 12 minus 5x over 3 is the inverse of this function. Find the value of x when f of x is 4 more than g of x. F of x is 4 more than g of x. Your f of x was 2x plus 3 and g of x is 12 minus 3x over 5. So let's solve this. Okay, so let's solve this. So it's going to be 2x plus 3 minus 4 equals to 12 minus 3x over 5. 2x minus 1 equals to 12 minus 3x over 5. Cross multiply 5 with 2x minus 5. So 5 times 2x minus 1 equals to 12 minus 3x, which is 10x minus 5 equals to 12 minus 3x. Swap 3x with 5, so 10x plus 3x equals to 12 plus 5. 13x equals to 17, and x is 17 over 13.